Continuing talking about circles. This lesson we're going to talk about inscribed angles and intercepted arcs. An inscribed angle is an angle whose vertex is on the circle, which means it's on the edge of the circle, and the sides contain chords of the circle. So if two chords come together on the edge of the circle, then that is called an inscribed angle. Okay? An intercepted arc is the arc. Y'all know that arcs are the edges of the circles, right? Different pieces of the edges of the circle. Is the arc that lies in the interior. What does interior mean? Inside of an inscribed angle and has endpoints on the circle. So this is the inscribed angle right here. This blue part that I colored blue is the arc that angle intercepts. Okay? Y'all know what an interception is, right? When you catch a pass, right? Well, that's from the other team in football. But if you intercept an arc, that means the angle, the two chords that make an angle, is what goes in between it. Like those chords kind of capture that arc. All right. So here's a theorem, and I think you have a fill in the blank on your handout. The measure of an inscribed angle is 1/2 of the measure of its intercepted arc. The measure of an inscribed angle is 1/2 of the measure of its intercepted arc. Okay? So the inside angle will be half of the intercepted arc. You know, angles have measures with degrees, arcs have measures with degrees. And if we know the inscribed angle, we can double it and get the arc. Or if we know the arc, we can half it and get the angle. Okay? So, look at this picture. This would be one we would write on our notebook paper, because this is a problem. So we're going to work some problems with our circles today. Do a little numbers. It says find the measure. Now I wrote on there, these are not drawn to scale. And there's you a little plug for ACT. Guess what? On your ACT test, when you take it, pictures are not drawn to scale in geometry on purpose. They want you to look at it and say, that's a right angle, when there's no little box showing you it is. Okay? So you can't assume measures unless they give them to you. So, they first want us to find the measure of angle T. Now that's an inscribed angle right here. Now what did that theorem that we just say? Alright, do we know the intercepted arc that angle T intercepts? That's the minor arc RS, right? So here's angle T. It's intercepted by the arc RS, or it intercepts the arc. And we know its measure is 48. So angle T, how are we going to get that? We're going to have 48, which is divided by 2. So what's half of 48 degrees? 24 degrees. So the measure of angle T is 24 degrees. And if you want to put that on your picture, you can. Does that make sense how we got that one? We know the outside arc, so we have it. Now, number 2 wants us to find the measure of arc QT. Well, here is arc QT. And it's intercepted by angle R, is it not? So how do you think we do it if we know the inscribed angle? How do we get the arc measure? You double it. Okay? So if we know the arc, we half it to get the angle. If we know the angle, we double it to get the arc. Does that make sense? So what do we get if we double 50? 100 degrees. Bless you. So I'm going to put this out here because I might need it. Okay. So now it wants us to find the measure of arc QR. It's a minor arc. How do you think we could do that? Keep in mind this is not drawn to scale. Well, you don't know TS. So we can't do 360. What, Will? Yep. Goes through the center. Even though it's not drawn the scale, it already tells us it wasn't, right? That's right. This makes a semicircle. Right? Because wherever the point is, that's your center. So if a chord goes through the center, it's the diameter. So for the arc that connects the diameter is a semicircle, which is 180. So what is the measure of minor arc QR going to be? 80 degrees. 180 minus 100 is 80 degrees. Y'all see how we did that? So look for those diameters. Okay? Good job. Here's another cute little picture for us. Y'all don't have to draw the picture. Well, you might want to. Whatever, it's up to you. I ain't going to force it on you. So the first thing it wants us to find is the measure of arc RS, which is this one. How are we going to get it? Right. The inscribed angle is half of the intercepted arc. And you notice this angle from S, U, and R makes this arc, right? Inscribes that arc, or intercepts the arc, so I should say. So if the inscribed angle is 31 degrees, then what's the measure of arc RS? You double it and get 62 degrees. Does that make sense? So the next thing it wants us to find is the measure of angle STR. STR. This angle T right here. This inscribed angle. Well, what do you notice about it? It's also intercepting the same arc, isn't it? Y'all see that? They're sharing that arc because this angle intercepts this arc and this angle intercepts that arc. So what's its measure? It's going to be half of 62, which is 31 degrees. So what do you notice about those two angles? They're the same. So I think we can say that if two inscribed angles intercept the same arc, then they are congruent to each other. And I think that's what the next theorem says. Oh, that's exactly what the next theorem says. If two inscribed angles of a circle intercept the same arc, then the angles are congruent. So your magic word to include in your notes is intercept. So on this one, AB is intercepted by angle D. It's also intercepted by angle C. Therefore, D and C will be congruent to each other. So that's a nice little theorem. All right, so this one you don't have to write this one down. Just pay attention with me. Name two pairs of congruent angles in this figure. Angle K and angle L both intercept JM. So angle K is congruent, not congruent. It's one squiggle, two equals. To angle L. What else? Is there another pair? J and M intercept KL. So they're congruent to each other. Very good. Y'all see that? So these two are going to be congruent and these two are going to be congruent. They intercept the same arc. They are congruent to each other. All right, this is another definition for you. Two definitions. Oh, I'm off the screen. Inscribed polygon and circumscribed circles. Inscribed polygons and circumscribed circles. So an inscribed polygon is a polygon that has all of its vertices in the circle. So the circle kind of goes around it. However, the circle touches all of the edges of that polygon. Touches all the corners, all the vertices. So here's a picture down here of some inscribed polygons. This is an inscribed triangle because all of the vertices of the triangle are touching the outside of the circle. Here's an inscribed quadrilateral. It's got 4 sides and all 4 vertices are touching the edge of the circle. Okay? So if we have an inscribed polygon, then that means the circle is called a circumscribed circle. Okay? So the polygon is called an inscribed polygon because it's inside a circle with all the edges touching it. Okay? The circle is called a circumscribed circle. Okay? Yes, sir.
What if you have a polygon that doesn't, it's inside the circle, but it doesn't?
It's not an inscribed polygon. It's just in there. It's just in there. Okay? But to be inscribed, it has to touch all of its vertices to the edge. Vertices. All right. So circumscribed circle is a circle that contains all the vertices of a polygon. So we got some little properties. This is your long property on there. And I think there's not even any blanks, right? So just read that along with me. If you want to, you can draw a little picture. It says, if a right triangle, you might want to highlight the word right triangle or underline it or box it. That's an important part of that phrase. Is inscribed in a circle, then the hypotenuse is the diameter of the circle. So if a right triangle, if we know that one of the angles is a 90-degree angle of a triangle, is inscribed by a circle, then the diameter is the hypotenuse. Conversely, what does that mean? That means we're talking about the converse, okay? If one side of an inscribed triangle is a diameter, then the triangle is a right triangle. So if we know the diameter is a side of a triangle, then it will be the hypotenuse of a right triangle. So both ways. Okay? And then this is a theorem about quadrilaterals inscribed. This is the bottom of your notes on your handout. It says a quadrilateral can be inscribed in a circle if and only if opposite angles are, what's that word? Supplementary. Opposite angle. If it's a quadrilateral, it means it has how many sides? 4. So if a 4-sided figure and 4 vertices is inscribed by a circle, then opposite angles are supplementary. So for example, D and F are opposite angles. That means they're non-adjacent, non-consecutive. They're across from each other. So D and F would make how many degrees? Supplementary means add to make 180. Okay? So D and F would add to make 180 degrees, and E and G would add to make 180 degrees. So opposite angles of an inscribed quadrilateral, opposite angles are supplementary. So now we can do some math. So this needs to be on your notebook paper. These pictures are a little bit difficult to draw, doing it by yourself. Because I don't know about you, but I don't make really pretty circles by myself. When I was y'all's age and I was sitting in class, I kept a bottle cap with me in geometry class. Because they were perfect size for little circles on my notebook paper. And I would trace a bottle cap. I'm OCD like that. Those are a little bigger. And also, like, you would use the side that's not bumpy. Because this side's bumpy, so I'd probably turn it upside down. Water bottles are usually smoother than Coke bottles. Yeah, I've done it all. But yeah, Gatorade bottles would be good. All right, find the value of each variable. Now, this is an inscribe what kind of polygon? Quadrilateral. So what do I know about inscribed angles of quadrilaterals? Opposite angles are supplementary. So, for example, if I start with 75 and y, they're opposite angles, therefore that means their sum of their measures is 180. So you could say 75 plus y equals 180. And you would subtract 75 from 180, and y equals how many degrees? 105 degrees. There you go. And then if you want to find x, it is supplementary to angle Q, which is 80 degrees. So you would say x plus 80 equals 180, and subtract 80 on both sides, so x equals how many degrees? How much? 100. Does that make sense? Nice and easy. And you can check it because if you add all four angles inside of a quadrilateral, they should be 360. We learned that a while ago. So look at this one. Y'all don't have to draw the picture. Can y'all just help me do the math? What do y'all want to find first, A's or B's? A's. So these are opposites. So you can say 2A plus 2A equals what? 180. What's 2A plus 2A? 4A equals 180. And then you divide by 4, and A equals not 90. 45 degrees. There she is. All right. So the next one, how are we going to get our B's? So these two are opposite angles. Therefore, they will be supplementary as well. So 4B plus 2B equals 180. Combine your like terms. What is 4B plus 2B? 6B. Divide by 6 everywhere, and B equals how many degrees? 30 degrees. So any questions on those? La-li, 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 la-la-la. A little bit more complicated. This will be the last one for this lesson. Let's get them C's first. Get done with that one. Okay, so these two are opposites. And the measure of angle U down there is 2C minus 6. But together, those opposite angles will make how many degrees? So you can say C plus 2C minus 6 equals 180. And then combine your like terms. What is C plus 2C? 3C minus 6 equals 180. Then what? Add your 6. So 3C equals 186. And then you divide by 3, and what do we get? 62 degrees. Everybody okay with that? And then how would we find X is? Okay. 8x plus 10x equals 180. Combine like terms. And then you divide by 18, and x equals 10 degrees. So, are there any questions about using opposite angles in a inscribed quadrilateral? All right. That is the end of section 10.4. So now we are going to go on over to section 10.5. Section 10.5. And I'll give you a second to get situated and fill in that first theorem. I'll actually go ahead and scroll so you can see those next two pictures. So we're going to talk about other circle relationships in this section. Basically, angles intersecting inside and outside a circle is what we're going to get to. So there will be some more algebra coming our way. It says, if a tangent and a chord intersect at a point on a circle, then the measure of the angle formed is half the measure of its intercepted arc. So this is basically the same kind of theorem we talked about with inscribed angles, but this is dealing with tangent lines. Okay? Now what does it mean for a line to be tangent to a circle?
It means that one point touches the circle.
Yes, that means I touch the circle in only one place. I don't go through the circle. That would be a secant. Right? So a tangent means I only touch it in one place. So it's like the line, the circle kind of sits on the line, like this one's doing right here. Okay? So if that's the case, then the angle formed is half the measure of the intercepted arc. Okay? So it's similar to inscribed polygons or inscribed angles, but it's dealing with tangents. Okay. So these examples right here want to find the measure of the red angle or arc. So on the first problem, is the red an angle or an arc? It's asking you to find the angle, the measure of angle 1. And so did it give you the intercepted arc measure? Yes. So if the inscribed angle is 1/2 of the measure of the intercepted arc, how do we get the inscribed angle if we know the arc measure? Divide in half. Right. So what is 130 divided by 2? 65 what? Degrees. Y'all see how we got that? On this one they gave us the arc, so we took half of that to get the angle. Doesn't look like that's drawn to scale because that looks more like a right angle, closer to 90. All right. The next one, they give us the inscribed angle measure and want us to find the measure of the arc. So how do you think we're going to find the arc measure? Right. Because if it's half the measure of the arc, if we know the angle to get the arc, we have to double it. So what do we get when we double 125 degrees? 250 degrees. Does that make sense? So if they give you the angle, you double it to get the arc. If they give you the arc, you half it to get the angle. Questions? Okay. There are 3 ways that lines can intersect on a circle. They can intersect inside the circle, outside the circle, or on the circle. So if they intersect on the circle, you usually have a tangent. And there's pictures of that on 681. But we're going to basically talk about inside and outside. We're going to talk about inside and outside. So I'm going to hush for a second and let y'all write that down. And on your notes, you need to write those little formula. Measure of angle 1 equals 1/2 arc plus arc. Let me scroll back up so you can get my picture. Drawing the picture is helpful too. So I kind of color coded my picture of my circle there. So the reds go together and the blues go together. Okay, so if I have two chords that intersect inside a circle, then the measure of each angle is half the sum of the measures of the arcs intercepted by the angle and its vertical angle. Okay, so if I look up here, I'm going to erase my colors for just a second and I'll put them back on. So that angle 1 right there, don't this vertical angle, isn't it the same measure? They're vertical angles, and we know vertical angles are what? Congruent. So if I want to find the measure of angle 1, I take the two intercepted arcs made by that angle and its vertical angle. I add them together and I take half of that number. Okay, so I add the two intercepted arcs together and then I take half of that number, and that will be the measure of angle 1. Okay, likewise for angle 2, it's intercepted by this arc. Its vertical angle is right here above it, and the vertical angle is intercepted by this arc. So if I want to find the measure of angle 2, I add those two intercepted arcs together and take half of it. Okay? So that's what you do for angles inside a circle that intersect. Sometimes lines intersect outside of a circle, like what happens right here. So if two lines cross inside a circle, you add the two arcs and take half of them. If two lines intersect outside of the circle, now it could either be because of two tangents, or because of two secants, or because of secant and a tangent. Okay? But either way, if the lines touch outside the circle, here's where they cross, then this angle measure is going to be half of the difference of the two arcs. So if they intersect inside, you're going to add and take a half. If they intersect outside, you're going to subtract and take a half. Inside you add, outside subtract. Inside you add, outside you subtract. That's why I have that highlighted right there over to the side. So you might want to write that down somewhere on your paper where you can see it. Inside you add, outside you subtract. And all of them you're going to take a half. So those two pictures I showed you, I have two tangents, and then I have two secants, And then, but you can also have a secant intersecting with a tangent. I just didn't draw that picture. So when you find the difference of your arcs, you're obviously going to do larger minus smaller. So you're going to say the larger arc minus the smaller arc, and then take half of it, and that'll tell you the angle measure where the two lines cross. And then we're going to work some problems with these, and then we'll be done for the lesson for the day. Okay? All right, can I scroll? All right. Let's do some problems. I'm going to let y'all draw that lovely circle. So can't see it. This top arc measure JM is 130 degrees. The bottom arc measure is 156 degrees. All right, are those two lines intersecting inside the circle or outside the circle? Yeah, the lines are crossing inside the circle. So to find the measure of angle X, you're going to say 1/2 times the measure of the two arcs added together. Inside we add. Inside we add, outside we subtract. They cross inside we add and take a half. So 130 plus, that's how we set up our problem. We're going to add the two arc measures outside, then take a half of it. So what is 130 plus 156? 286 degrees. And what's half of that? 143 degrees. So X is 143 degrees. Pretty simple. So if it's inside, we add them and take a half. Outside, we subtract the arcs and take a half. Can I scroll? We good? All right, now we want to find X's degree measure on this end. Listen at me, on this one problem. Now, are these two lines intersecting inside or outside the circle? Outside. So we got a tangent right here. CD is a tangent line to the circle. CA or CB is a secant to the circle. They cross at point C. So that's two lines. I got a tangent and I got a secant. They're crossing at point C. Okay? So these are intersecting outside the circle. So if you don't see an X in the inside of the circle, it's outside the circle. Does that make sense? Intersecting inside the circle, you see an X inside the circle. All right. So this one is outside the circle. So what are we going to do to our arc measure? So the measure of angle, I guess it'd be angle C, but we're going to say X, is going to be 1/2 the measure of the two arcs' difference. So the larger arc is 178 degrees, and we're going to subtract. Does that make sense? They intersect, that angle intercepts this arc and this arc. So you find the difference of those and then take a half. So what is 178 minus 76? And what's half of 102? 51 degrees. So that angle measure right there is 51 degrees. So this is really not difficult. You just got to look and see if you're intersecting inside or outside. So that is all for today's lesson. Have a good day.